Alright, this chapter discusses the equipment and material used in gas welding. The information provided with the operation manual of the oxy-acetylene oxy map equipment included with the welding technique with the safety precaution associated with the gas welding, oxy-acetylene oxy methyl acetylene propropylene welding are two types of the gas product for the gas fuel torch ready for the temperature for the two similar pieces for the middle of the use from the point that allows them to flow together. Fill a rod for the deposit of additional metal of the gas oxygen makes the correct portions of the torch. You can adjust the torch produced various types of flames, properly made gas weld, consistent appearance for showing uniform deposit welding material with a complete fusion side weld, the necessary form of the good joint. Some factors you must consider whether making a gas weld are follows edge preparation, spacing, alignment of the parts, and temperature control of the before and during and after the welding process. Side of the torch, shift the side of the tip of the filler rod with the flame adjustment rod, torch, or manipulation. Some of the cases of flux is the need to remove the oxidized flags from molten metal, protect the puddle over the atmospheric contamination. When you select join section gas welding, edge of the plate joint uniformly melted with the heat of the torch. Welding heavier sheets and plates where you have to fill it. Use filler metal at the edge of the heavier plate or bevel to permit penetration to base joint, both filler metal and the base metal of the melted and solidify with a form one continuous piece. For welding light sheet metal, filler metal is usually not necessary. The edges light sheet metal are flanged jointly as flow together to form one solid piece. You melt them. Oxy gas welding equipment. Oxy gas welding outfit basically the same as oxy gas cutting outfit with expansion torch welding outfit. Usually consists of cylinders, an acetylene map, gas cylinder, oxygen tube regulators, two lengths hose with fittings, and welding torch for the tips. As an oxy gas welding outfit is called the welding rig. In addition, with a basic equipment managed also the same auxiliary equipment with discussed in chapter 4. Equipment consists of the tip cleaners, cylinder trucks, clamps, holding jigs, safety apparel, which includes goggles, hand shield, gloves, layer, aprons, sleeve leggings is essential, should be worn and required information. Safety apparel is contained in chapter 3. Oxy gas welding equipment like cutting equipment must be stationary portable oxygen gas cutting shown in figure 5.2 is advantage when it becomes necessary to move the equipment. Perform welding duties. You must be able to do a setup of the welding equipment to make adjustable required to perform welding operations. That's important when you understand the purpose of function with the basic pieces of the equipment to make up the welding outfit. Gas cylinders, regulator, hose, safety equipment covered in chapter 4. If you have any questions, you should review the chapter 4 before continuing. Welding torch is oxy gas. Welding torch mixes the oxygen fuel within the proper proportions. Control for the amount of the mixture burned in the welding tip. Torches have two needle valves, one adjusting oxygen flow, other adjusting fuel gas flow. Other basic parts include the handle, body of the two tubes, one oxygen, another fuel mix heading and a tip. Some models of the tubes are silver braided with the heads of the rear end forging, which are in turn fitted within the handle. Welding tips are made with a special copper alloy available in different types of the handle, wide range. Use plate thickness. Two general types of welding torches: low pressure, medium pressure. Choose oxygen regulator, oxygen cylinders, oxygen safety valve torch, oxygen valve torch, fuel gas valve, fuel gas hose, oxygen hose, fuel gas hose, cylinder gas run, fusible plug, cylinder support, maps, acetylene cylinder, fusible plug, cylinder gas cylinder, oxygen cylinder. Low pressure torch is also known as injector torch. Fuel gas pressure is 1 psi. Per pound per square inch. Oxygen pressure ranges between 10 to 40 pounds psi, depending on the size of the torch tip. A jet relatively high pressure oxygen produces the suction necessary to draw the fuel gas into the mixing head. Welding tips may or may not have separate injectors in the tip. The typical mixing head with low pressure or injector typical torch shown in figure 5.3. Medium pressure torches are often called balanced pressure equal pressure torches because the fuel gas and oxygen are kept equal. Operating pressures depend on the type of the tips used. Danger: if the acetylene of the fuel gas pressure must never be allowed to exceed 15 psi. Acetylene pressure may be very dangerous at 15 to 7 and self-explosive at 29.4 psi. Oxygen fuel gas injector nozzle. Oxygen fuel gas injector nozzle. Equal pressure welding hose, oxygen connection gland, fuel gas hose connection gland, fuel gas hose nut, oxygen connection nut, fuel gas needle valve, oxygen tube, fuel gas handle, torch head, oxygen needle valve stem, oxygen needle valve body, mixing head nut, mixing tip, copper tip. Typical equal pressure welding torches are called the general pressure torch shown in figure 5.4. Medium pressure torch is easier, just a lower pressure torch, and since equal pressure gas pressure, you'll be likely to get flashbacks are covered in chapter 4. Welding tip mixers designed several ways depending on the manufacturer. Some torch design that separate mixing head and mixture for each for the type and size. Other design have only one mixture for the several tip sizes. Tip comes in various types, as some of the other one-piece hard copper tips, the other for the two-piece tips. Include the extension tube with the make of the connection between the tip of the mixing head when you with the extension tube with the removal of the tips made with the hard copper, brass, and bronze. Tip size is designated by numbers. Each manufacturer has its own arrangement classified them. Tip size differ in the diameter of the hole. Filler rods. Filler rods refer to filler metal used with the gas weld with the brazing certain electrical welding process in which filler weld is not part of the electrical circuit, but the only function of the filler rod is supply with the filler metal to join. Filler rod comes from the wire rod form, but they often referred to as welding rod. As a rule, filler rods uncoated except the thin result of the manufacturing process. Filler rods, welding steel, often copper coated and protected them with the corrosion during storage. Most rods are furnished at 36 inches length with a varied variety of diameters ranging from 1/32 inch to 3/8 inch. Rods with the welds in cast iron vary from 12 to 24 inches in length and are frequently square rather than round. We determine the rod diameter given them rod job thickness for the metal or joining. Separate rod diameter used to select with the filler rod based on the specification metals with being joined. Specification federal military naval specification means that apply with all federal agencies, military establishment, or the Navy respectively. Filler metals are presently covered by one or more of these three types of specification. Eventually, all Navy specifications will be rewritten military specs. For the reason some of the specifications of the welding material presented in this section may be subsequently published as a military rather than Navy specification. Many different types of rods manufactured for the welding, ferrous, non-ferrous metal. In general, the welding shop stock only a few basic types that are suitable to using all welding positions. These basic types are known as general purpose rods. Operation maintenance for the oxygen and gas equipment. These sections discuss the basic procedures involved in setting up the oxygen gas equipment, lighting off, adjusting the flame, and securing the equipment, and information also provided with the maintenance of oxygen gas equipment. Or selecting the welding torch tip size. Welding torch tip size is with the number stamped on the tip, with the tip size determined by the side of the oar. There's no standard system for the numbering welding torch tips. Each manufacturer has its own numbering system manual. Tip size is given the number of the drill, or if the number of drills consists of the series. If it's 80 drill, the number 1 through 80. Diameter number 1 drill is 22.80 inches. The diameter of the number 80 drill is 0.135 of an inch. As the drill size number increases, the size of the drill increases. Once you become familiar with the use of the specific manufacturer's torches, numbering system becomes necessary to refer to the orifice number, drill size of the orifice size that determines the amount of fuel, gas, oxygen fed to the flame, therefore determines the amount of the heat produced by the torch. The larger the orifice, the greater amount of the heat generated. If the torch orifice is too small, not enough heat will be available to bring the metal to the fusion temperature for the torch tip. The larger pour welds result of the following. The weld is made too fast for control of the welding rod melts. The difficulty appearance of the quality of the weld is unsatisfactory. For practice purposes, using the equal pressure for the welding rods for the tip of the shown in the table 5.1 will give the satisfactory result. Equipment setup. Setting up the oxygen gas equipment. Preparing the welding identical. Setting up the oxygen cut, except for the selection of the torch tip. Select with the correct tip of the maxing head, but depending on the torch for manufacturer connection, the torch body. Tighten the assembly within adjust to the proper angle. After desired adjustment has been made with the tighten the tip of the one size of the type of the equipment. Tightened with a wrench, while the other types only with a hard hand tighten them as required. Torch lighting and flame. Adjusting the lighting of the torch. Adjusting the flame. You should always use the following manufacturer direction for the particular model of the torch being used necessarily because of the procedure vary from somewhat different type of the torch. In some cases, either with the different models made by the same manufacturer. After lighting the torch, you just adjust the flame according to the type of the metal being used and the depth of the coverage of the different type of the flames covered in Chapter 4. Carbonizing flame is adjusted for the welding. High carbon steel with a hard face of the weld. Non-ferrous alloy with a mild with a neutral flame. If the correct flame of the welding. More miles out of the steel with a weld. Flame puddle molten metal with a quite clear with the metals. Flow with the boiling, foaming spark of the welding flame. Show with always adjust for the neutral before there's oxidizing carbonizing flame mixture. Oxidizing flame is limited to the harmful and many metals applied with the shield of the oxidizing flame, caught with the molten metal of the foam produced with the spark of the major use of flame and slightly oxidizing flame from use of brace steel with the cast iron strong oxidizing flame and use the fusion welding brass and bronze determine the amount of excess oxygen used to wash the molten metal. Maintenance of the equipment and welding equipment to operate with proficient efficiency gives you useful life. You must properly review the maintenance upkeep on it. Your responsibility involved with the maintenance care of the oxygen gas weld equipment will not require to make major welds or welding equipment, but major repairs are needed if responsible to see that the equipment is removed, the service and turned into the repair section. Briefed on some of the common type of the maintenance duties you will be required to do. Torch gas leaks. At times, needle valves may fail to shut off when the hand tightened with the usual manner. With this happen, do not use the wrench to tighten the valve stem. Instead, open the valve and try to blow out foreign matter out of the valve seat using work gas pressure in the hose. If this fails, it will be necessary to remove the stem assembly, wipe the seat clean, reassemble the valve, try closing it shut tight by hand several times. If the measure fails, stops the leak, you should have these parts replaced with the valve body reseated. These repairs should be made only by qualified personnel. When the leakage around the torch valve stem, you should tighten the packing nut and repack if necessary. If repacking, should only the packing recommended by the manufacturer. Do not use any oil if the valve stem is bent and badly worn. Replace it with a new stem. Before you use the new torch for the first time, have a good idea of the check with the packing nut of the valve is made with the sure of the type with the reason that some of the manufacturers ship the torch if it's not thus to lose the leaks of the mixing headset, with the torch cover the oxygen fuel gas leaks between the intel inlet orifice leading to the mixing head of the problem cause of the improper gas of the mixing result of the flashback probability corrected avenue C of the torch head ream chewing the mixture head C with the usually with the most said the equipment to manufacture of these repairs. 5.5 shows a welding tip orifice cleaner. 5.6 shows a welding tip cleaner. 5.7 shows reconditioning an orifice end of the torch tip. Welding torch tips. Welding tips are subject to considerable abuse that must be kept orifice smooth with the cleaning for the tip of the perform satisfactory when the cleaning of the welding tip. You must be careful to ensure that they do not enlarge and scar of the orifice. Carbon deposit of the slag must be removed with the regulator to ensure the good performance. Avoid dropping and dragging the tip because of the sheet with the seal of the joint may be damage the flame end of the tips, but also may refute the damage if it's allowed to come in contact with welding work and a bench from failure break the damage roughness the end of the tip of the flame to burn with the flash fish shell. Special welding tip cleaners have been developed to remove the carbon slag of the other tip over the cleaner, control the series of the broach, like wires of the corresponding to the diameter of the tip over the wires are packaged in a holder with the banks for the safety and convenient. Figure 5.6 shows the tip cleaner in use. Some welders prefer to use the number drill side with the tip orifice to clean welding tip of the orifice. The number drill size may be carefully so the orifice is not enlarged, bell-mouthed, reamed out, round, or otherwise deformed. Flame of the end tip must be clean and smooth. The surface must be right angle with the center line with the tip over to ensure proper shape of the flame. At 4-inch metal file with the file of the tip cleaner can be used to recondition surface as shown in figure 5.7. Reconditioning the tip becomes the rough and pitted of the orifice valve mouth. An easy method to use involves the place and pace of the emery cloth grit side up on the flat surface of the holding tip perpendicular to the emery with cloth run the tip back and forth enough that it is true with the surface to bring the orifice back to original diameter. Regulator gas leakage between the regulator seat and nozzle. The most common type of the trouble is usually overhear the problem referred to as the regulator creep of the problem is the to gradually arrive at the pressure gauge without moving the adjusting screw. Frequently, the trouble is caused with a worn crack seat. It also can be caused with a foreign matter lodged between the seat and the nozzle. It's important to have the leaking regulators replaced and once otherwise the personal equipment damage could result particularly with the dangerous fuel gas regulators because the fuel gas is high pressure for the hose becomes explosive hazard. To ensure safety of the personnel equipment, ensure the regulators with such leaks are removed from service and turned in for repair. Alright, oxy-gas welding techniques. Oxy-gas welding is done either the force or hand over the backhand method, the forehand method, or backhand method. Each technique should have special advantages. You should become skilled with the both. The deciding factor determines whether the technique is considerable forehand, backhand, if the relative position of the torch right during the welding, not. Direction of the welding bath method either depends on the type of the joint position needed for the control parts of the weld. Shows forehand welding, backhand welding. It shows the T-fillet, lap joint, overhead joint, and vertical. Alright, forehand welding. Figure 5.8 is often called the puddle ripple weld method of the welding. Skip the head of the flame in the direction which of the weld is being made with the point of the flame direction. Travel the whole of the tip of the angle of about 45 degrees of the work. Travel the flame position. Preheat the edge of the weld. Adjust the head of the bolt and bevel. Move the rod of the same direction. Have the tip of the move of the torch. Strip of the welding rod back with the fourth of the opposite of the similar circle pass for the condition for the heat evenly with the flame pass of the welding rod. Short length with the rod adds with the power with the motion with the torch. Distribute the motion metal evenly both ends of the joint with the molten puddle. Forehand method uses all positions for the welding sheet. Light plate 1/8 of an inch thick. Method's ideal for the permanent. Either better control of the small puddle results in a smoother weld and the forehand technique is not recommended for welding heavy plate due to the lack of base panel penetration. Alright, backhand welding. In backhand welding, the torch tip to perceive the rod direction of the weld, the flame point back of the molten metal will complete weld. The welding tip should make an adjacent angle with about 60 degrees of the plate, joint being weld to the end of the welding rod is placed between the torch tip and the molten puddle. Less motion is used in the backhand motion, method, and the forehand method, used the straight welding rod. You should rotate the end of the rolls of the side to side of the mounts off evenly. You may have to bend the rod of the working confined space. If you do, it becomes difficult to roll or bent rod, and it comes late. You have to remove the rod torch back further rather rapid. Making large rods, you should move with much of the complete circles model and paddle of the torch. Just remove it and further off of the weld while advance slowly uniformly direction of the welding. The backhand method is best for the welding material more than 1/8 of an inch thick. You can use the narrower V at the joint of the possible forehand welding and include an angle of 60 degrees, sufficient angle with a bevel of the good joint. Backhand method requires a less welding rod and puddling with the forehand method. By using hand technique with the heavier materials, you can improve the welding speed with the better with the control of the larger pulp that you have with the complete fusion welding rod. If you slightly reduce the flame with the backhand technique, a small amount of the base metal with the metal while welding the root joint while welding steel with a backhand technique with a slightly reduced flame absorption of the carbon and its thin surface of the metal reduces the melting point of the steel with the speed of the welding operation. This technique is used in surfacing with the chromium cobalt alloys. Multi-layer welding used in order to avoid carrying large molten metal puddles to the weld. Thick plates and pipe. Large puddles are difficult to control. Concentrate on getting a good weld at the bottom of the V in the first pass, then in the next. Concentrate the greater, getting good fusion on the sides. The V, the previous layer, the final layer is easily controlled. Smooth surface of the welding has an advantage of the refines. The previous layer's succeeding layers made in effect for the heat treat the weld material by allowing one layer to cool back heat before it's reheated to improve the ductility of the welded metal. If this added quality is desired for the last layer with an additional succeeding layer is deposited and then machined off. Alright, joint edge preparation. Sheet metal is easily melted, does not require special edge preparation. Welding operation involving plate, joint edge preparation, proper spacing between edges are important factors. Thickness of the plate determines the amount of edge preparation required. Face of square edge can be butted together but welded. You can use the time of the joint and plate with a 3/16 of an inch thick and for a 3/16 to 1/4 of an inch thick. A slight root opening between the parts is necessary to commit a complete penetration plate. More than 1/4 inch thickness requires beveled edges on a root with an opening of 1/16 of an inch for oxy gas welding on a plate more than 1/4 inch thick. Bevel edges at the angle 30 to 45 degrees, making the groove that include the angle of 60 to 90 degrees. You can prepare the edge of the flame cutting, shearing, flame grooving, machining, chipping, and grinding in case of the edges surface with a free oxide scale, dirt, grease of the foreign matter. Plate of 3/8 of an inch, 1/2 inch thick can be welded from one side only, but thicker sections should be welded, preparing edges both sides. Generally, both joints should prepare with the both sides permit easier welding, produce less distortion, ensure better weld qualities. Heavier steel plate rarely weld oxygas unless the type of welding equipment are not available. And welding a heavy plate is not cost effective because of the amount of gas consumed in time used for the complete weld, and impossible uniform electrical arc welding because the joint can be welded faster, cheaper, and there's less distortion. Oxy-gas welding of furious metals. Low carbon steels, low alloy steels, cast steel, the wrought irons are easily welded by the oxy-gas process. Flux not necessary when the metals become there's oxidized melts at a low temperature than the base metal. During the welding process, you can cover the molten metal with a flame envelope to ensure the molten metal does not contact with the air. If the metal is exposed to the air, it will oxidize rapidly and the air should overheating the metal. Proper flame adjustment is required to make the good weld. Adjust the flame in the neutral slightly. Reducing carbonizing flame. Do not use the oxidizing flame of the manipulate the torch rod the type of the oxygen gas cone 1/16 inch, 1/8 inch from the surface of the metal end of the filler rod and puddle, not with the flame welding. The low carbon steel of the steel presents no special problems over the selection of the proper filler rod. Low alloy steel usually require pre-welding, post-heating, heating treatment. The heat treatment will relieve the stress that develops during the welding phase that produces the desired physical property of the metal. A carbon content steel increase with the welding becomes difficult. Steel whose carbon content is within 0.3% of 5% or 0.5% range, welded with slightly carbonizing flame. Low carbon steels will most require post-welding heat to develop the physical properties. High carbon steel tools require slightly different technique protecting the parts from the graft. Slowly preheat them about 1000 degrees. Complete the weld rapidly possible. Carbonizing flame, no flux. Do not manipulate either the rod or torch and filler metal into small amounts as if needed. You can use the smaller flame, low gas pressure, then use and lower carbon steel to ensure that you can do not overheat the steel. You must heat the treat in hydrocarbon steel. The tools after welding develop the physical properties required. Procedure oxygen gas, wrought iron steel, same in the low carbon steel, mild steel, however, that you should keep the several points in mind. Right iron steels. Contained slags was incorporated with the during manufacture stage. The slag gives the surface of the molten puddle with a grease appearance. Do not diffuse gaseous appearance with the appearance of the actual fusion. Containing heating only in the sidewalls of the joint. Break down into the puddles. Best results with the wrought iron obtained in filler metal. Usually mild steel. Base metals are mixed with the molten puddle minimum aggregation. Oxygen weld cast irons are not difficult but does not require modification procedure used within the steel for more than not exceeding 3/16 of an inch. Thickness, you do not make a V-groove metal should the less than 3/16 of an inch or 3/8 of an inch should have a single V butt in your joint included to the angle of 60 degrees. For more than 3/8 of an inch thick, use a double V point 60-degree angle. Before you begin preheating the entire weld at a temperature of 750 to 900 degrees Fahrenheit, welding should be done in neutral flame using backhand method to cast iron filler metals. The appropriate flux is necessary because of the separatingly is needed. Add filler directing the inner cone of the flame against the rod instead of dipping the tip into the rod of the puddle. Filler metal should be disposited in layers but not exceeding 1/8 of an inch thick. Upon completion of the weld, you must stress relieve the weldment heating of the temperature between 1100 to 1150 degrees Fahrenheit. This tool is slowly some gas weld cast iron gives a good color match and good machinability. However, the color it made is not essential. Cast iron repair can be made more easily economically by brazed welding. Oxy-gas welding can be used with more than chromium, nickel, and steels and stainless steels. Over the rule, oxy-gas welding uses only light sheet, heavier piece of the steel, usually joined by one or more of the electrical arc welding process. The materials, 1 gauge or 4/100 of an inch, less than thickness flange, equal the thickness of the metal turned up, then welded made with the filler metal. Before welding, should clean the jointed surface, fill up the metal with sandpaper with a brace within in place of stainless steel. Torch tip the welding. Stainless steel is usually one of the two sizes smaller than the tip. Use the weld metal steel the same thickness. Adjust the torch so you can carbonize the flame seen through the goggles. Excess fuel gas feathering exceeding 1/16 of an inch beyond the tip of inner cone. Hold the torch and flame makes with the angle 80 degrees or surface of the sheet. Tip of the cone should almost but not quite touch the molten metal. Make the weld in one pass. Use the forehand teak. Do not puddle or retrace the weld. Uniform speed of the welding is essential. If it's not necessary to stop the welding process, reweld the section. Wait until the entire weld has cooled. Are oxy-gas welding non-ferrous metals. Although brazing and brazed welding are often an extension of the make extent joints in the non-ferrous metal, there are many situations where oxy-gas welding is just suitable joint design and same non-ferrous. Metals are ferrous metal. In most cases, the oxygen gas welding non-ferrous metals usually require mechanical cleaning of the surface before welding and using flux during welding. Filler metals must be suitable to base welding, being welded a separate section with aluminum. Aluminum alloys is included part of this chapter since you may need with a more detailed instruction welding these materials. Pure copper can be welded using an oxygen torch. High joint strength is required. Should be either the deoxidized copper that contains no oxygen. Neutral flame is either the flex required. One flame welding copper alloys with a higher thermal conductivity. Copper should preheat the joint at area temperature ranging from 500 to 800 degrees Fahrenheit. Use a large torch of welding, large size tip to supply with more heat in the joint that takes possible to maintain required temperature of the joint. If the welding is completely cool, the part slowly, other than extra volume of the heat required. The technique for the welding copper is the same as the steel. Copper zinc alloy brass. Copper zinc alloy brass can be welded using the same method of deoxidized copper. However, the silicone copper oxide using the welded brass rods, usually flux coated, uses additional fluxes is not required. Preheated temperature for these metals range between 200 and 300 degrees Fahrenheit. Copper silicone alloy, silicone bronze. Copper silicone alloy or silicone bronze requires a different oxy gas welding technique used for copper and copper zinc. You weld the material with a slightly oxidizing flame using flux, having a high boric acid content. Additional filler metal with the same composition base material. Weld the process. Dip the tip of the rod under the viscous film that covers the puddle. Keep the puddle small and the weld to solidify quickly. Word of caution: when welding copper zinc, you should safeguard against zinc poisoning by either doing all welding outdoors by wearing a respirator or both, depending on the situation. Copper nickel alloy. Oxy-gas welding copper nickel alloys require the surface preparation and preheating the flux used for this welding, and then paste applied with a brush to all of the part of the joint and welding rod. If the torch gives a slightly carbonizing flame, tip of the inner cone should just touch the base metal, but do not melt with the base metal. Aim with the more necessary to ensure the good fusion. Keep the end filler rod with the protection envelope of the flame, adding the filler metal without distributing molten metal with the welded metal. If possible, run the weld from one end of the joint to the other without stopping. After you complete the weld, cool the part slowly. Remove the remaining traces of flux with warm water. Alright, high nickel alloys. One gas weld with nickel alloys is similar to the copper nickel alloys. Good mechanical cleaning. Joint surface is essential for the joint design. Basically the same as steel with equivalent thickness. Include the angle of the V-bowl jets to approximately 75 degrees. May weld plain nickel without flux, but high nickel alloys require a special boron-free, borax-free flux. Flux is formed of a thin paste, should be applied with a small brush. The flux both sides of the seam at the top and the bottom of the filler rod. If the torch should give a very slight carbonizing flame, the tip selector should be the same size, one size larger than the steel for the same thickness. Flame should be softer than the tip of the cone kept in contact with the molten pool. Use a rod suitable with the base material. Always keep the rod wells within protective envelope of the flame. After the weld is completed, post-heat the part and cool it slowly. Remove the flux in the warm water. Lead oxygen gas welding leads require special tools, special techniques. Although you do not require flux, may ensure that the metal joint area is scrupulously clean. You may accomplish this by shaving the joint surface, scraping the wire, brushing them, and remove the oxidized form matter of the flat welding position. Square butt joint, satisfactory other position. Lap joint is almost exclusively when using lap joint. Edges should overlap each other, the 1/2 inch for the inch or 2 inches, depending upon the thickness of the lead. To weld lead, a special lightweight fingertip torch for the tip ranging from 68 to 78. If the drill size, adjust the torch to neutral flame and the gas pressure ranging from 1.5 psi to 5 psi gauge, depending on thickness of the lead. Length of the flame varies from about 1/2 inch to 4 inches, depending on the gas pressure used. When welding in the horizontal flat position, soft brushing flame most desirable, but when you're welding in vertical overhead position, better results are obtained more pointed flame. For exactly gas welding lead, you should ensure that the filler base metal is the same composition of the base metal. Molten puddle is controlled as distributed, manipulating the torch flame moves in a semicircular V-shaped pattern. Each tiny segment of the weld is made separately with the torch flicked out of the way of the completion of each similar circular V-shaped movement. The joints are made in the thin layered filler metal, not added during the first pass, but added on the subsequent passes. Welding lead alloy should wear a respirator type of the proof of the protection against lead fumes. Warning: lead fumes are poisonous. Aluminum alloys. When assigned to work non-ferrous metals, you can expect jobs that involve welding aluminum and aluminum alloys. Pure aluminum has a specific gravity of 2.7, the melting point of 1210 degrees Fahrenheit. Pure aluminum is soft, seldom used in the pure form because it's not hard and strong enough for structural purposes. However, the strength of aluminum can be improved by addition of the other elements to form aluminum alloys. Aluminum alloys use 90% pure aluminum, silicon, magnesium, copper, nickel, magnesium are added to the aluminum, and aluminum alloy stronger than metal steel results, but pure aluminum is only about 1/4 as strong as steel. Considerable number of aluminum alloys available to remove the aluminum alloys and sheet to make and repair locker shelf of the books and trays. Other containers you may also have to repair chair tables, other items, furniture that are made of aluminum alloy. Oxygas with aluminum welding. Aluminum alloys usually confine materials of 31 thousandths of an inch into 125 thousandths of an inch in thickness. Also, thicker material can be welded by oxygas process if necessary. However, the thinner material is usually spot and seam welded. Alright, melting characteristics. Before attempting to weld aluminum alloy for the first time, you should become familiar with how metal reacts when under welding flame. A good example of how the aluminum reacts with a heated can be seen if the place is a small piece of sheet aluminum welding table. Heat and neutral the flame. Hold the flame perpendicular to the surface of the sheet, bringing it to the tip of the inner cone, almost in contact with the metal. Reserve it almost without metal suddenly melts and run away, leaving a hole in the sheet. Now repeat the operation with the torch held at an angle of about 30 degrees of the plane surface. With a little practice, you will be able to melt the surface of metal without forming a hole. Now try to move the flame slowly along the surface of the sheet, melting a small puddle. Observe how quickly the puddle solidifies and flame is removed. Continually this practice, and you're able to control the melting. When you have mastered this, proceed to practicing actual welding. Start with a simple flange or notch butt and joint. Do not require welding rod. Next, you should try using welding rod, thin sheet, then casting. Alright, welding rods. Two types of alloy welding rods for gas welding. Aluminum rods are 1100 and 4043 rods. The 1100 rods due to the maximum resistance, corrosion, high ductility are primary importance. 1100 rods due to the welding, 1100 rods and 303 type aluminum alloys. Only 440 rod is used for greater strength, minimizing tendency for cracking. Also used with all other aluminum alloys and castings. Welding fluxes. The use of the proper flux in welding aluminum is extremely important. Aluminum welding flux is designed to remove the aluminum oxide chemical binding it, and gas welding oxide forms rapidly molten metal. It must be removed. The defective weld it will result. To ensure the proper distribution, should paint the flux on the welding rod surface to be welded. Aluminum flux, usually powder form, is prepared used for mixing water to form a paste, and then the paste should be kept in aluminum glass or earth-worn container. Because steel and copper containers tend to contaminate the mixture. It is essential for the blending flux of the being applied to the edges, flange joints, because no filler is used in these joints. In all cases, the flux should be applied with the bottom of the tap of the side of the sheet with the area of the weld. After finishing weld, it is important that you remove all trace of flux. You can do this by using brush hot water, aluminum flux, and the left thumb on the weld is curved of the metal. Welding preparation. Thickness of aluminum determines the metal of the edge of the preparation material of 62 thousandths of an inch. Edge should be formed at 90-degree flange. Height of the flange should be about same height, little heavier as the thickness of the material. 5510 view A. The only requirement of the flange is either the edge be straight or square. The desired material of 1/8 of an inch of it can be welded with the flange joint. No filler rod is necessary if you flange the edges. So this shows A and B edge preparation gas welding aluminum. Unbeveled buttered weld can be made in thicknesses of 62 thousandths of an inch or 188 thousandths of an inch, but in this application, the necessary to notch edges with an solid cold chisel in a manner similar to those shown in view B. Figure 10 edge notching is recommended in aluminum welding because it aids getting full penetration, prevents local distortion. All butt welds made in material over 125 thousandths of an inch or thick are usually notched in some manner. Alright, in welding aluminum more than 188 thousandths of an inch with the beveled edge of the road notch them and then shown in the view of the figure C. The figure 10 included angle bevel of maybe 90 to 120 degrees. After you present the edge of the piece properly, you should then clean the surfaces to be welded. Heavy oxide present on the metal surface. You may have to use a stainless steel wire brush to remove the dirt, grease, and oil can be removed by wiping the weld at the area soaked rag. Aluminum plate 1/4 of an inch thick or greater should be preheated at the temperature ranging between 500 and 700 degrees Fahrenheit. Aids avoiding heat stress. Preheating also reduces fuel oxygen requirements. Actual welding. It's important preheating temperature does not exceed 700. If the temperature does not go above 700 degrees Fahrenheit, allowable alloy may be severely weakened. High temperatures also cause large aluminum parts to collapse under their own weight. Thin material should be warmed through torch before welding. This slightly preheat helps to prevent cracks. Alright, welding techniques. After preparing flux speeds over the welding, you should pepper the flame in a small circle over the starting point until the flux melts. Keep the inner cone of the flame off the flux to avoid burning it. Inner cone of the flame should be burning flux, but necessary to clean the joint with applied new flux. New scrape of the rod over the surface at 3 to 4 second intervals, permitting the rod to come clear with the flame. Each time the leaf of the rod flame too long, it melts before the parent metal does. The scrapping action indicates what you can start welding overheating the metal. Maintain this cycle throughout the cause of the welding, except for allowing rod to remain under the flame long enough to melt a movement of all the metal needed for the practice. The movement of the rod can easily be mastered. Forehand welding is usually preferred for the welding aluminum alloys because the flame points away from the completed weld that preheats the edge to the weld that prevents too rapid melting. Holding the torch at a low angle of the welding and then material thickness of 188,000 of an inch or above. You should increase the angle of the torch to near vertical position. Change the angle of the torch, including the thickness of the metal, minimize the possibility of burning through the sheets during the weld. When welding aluminum's alloys of 188,000 of an inch thick, you have little need to impart any motion to the torch other than moving it forward on flange. Material care must be taken to break the oxide film as flange melts down. This may be done in ensuring the melted flange and the puddle rod. The puddling rod is the central puddle flattened and shaped for a 1/4 inch stainless steel welding rod. With aluminum alloys above 188,000 of an inch in thickness, you should give the torch a more uniform lateral motion. Distribute the weld metal over the entire width of the flux. Weld slightly back and forth motion. Assist the flux and remove the oxides. Dip the filler rod in the welding pool for the forward motion. Angle of the torch is directly related to welding speed. Instead of the lifting of the flame from the time to avoid melting holes of the metal, you will find it advantageous to hold the torch in flatter angle to do the work. Welding speed should be increased after the edge of the sheet is approached. The inner cone of the flame should never be permitted to come in contact with the molten metal, but be held about 1/8 of an inch away from the metal. In vertical position, when the torch is given up in an up-down motion rather than rotating one overhead position. A light back and forth motion is used in the same flat welding. Heat treatable alloy should be held with a jig for welding whenever possible. That helps to eliminate the possibility of cracking. Likelihood of cracking can also be reduced using a 40-43 filler rod. This rod has a large melting range of the allowing alloy being joined, which permits base metal to solidify before the weld puddle freezes. As the welded last area solidifies, all contraction strains are welded bead rather than throughout the base metal. May reduce weld cracking by attacking welding parts while they are in jig and then losing the clamps before completing the seam. As soon as the weld is completed, the work has had time to cool. You should thoroughly wash the weld. This can be done vigorously, scrubbing it with a stiff brush by water runs over it until all traces of the flux are removed. This is important because if any of the flux left on the weld, it can corrode the metal. And if hot water is not available, you may use the diluted solution of 10% sulfuric acid. Acidic solution should then be washed off and cooled with fresh water after using. Show the welding operation back-end technique. Section 8 shows the average position of the rod flame in a puddle. Respect. Area being the V being meted, direction of weld, movement of the flame, and advancing puddle. Rod, part of the end of the welding rod in the molten pool, solidified weld and metal. Areas beginning to melt. Plastic weld melt flame. Alright, fused welding pipe and oxygen welding pipe. Many tests have improved the fusion welding pipe joints properly made are strong as pipe itself. For itself, the oxygen welding pipe, 3 essential requirements are met or must be met. It must be conveniently source of controlling heat available to produce rapid and localized melting of the metal. Oxide presence of the surface edge of the joints must be removed, and a metal joint unit by edge of the surface of the tube that is being joined must be made in molten metals. One method for even welding steel with a wrought iron pipe fusion welding. One method even welding wrought iron pipe that's done with fusion weld. This method involves melting the pipe and adding metal from the rod. Similar composition welding operation performed at the top of the joint. Horizontal pipe showing diagrammically. 511. This shows the backhand weld technique. The rod and flame are moved alternately toward away each other, as shown in Figure 512. Full strength oxygen weld. Oxy-gas welds can be made in any weld position. Cohesiveness of molten metal with the pressure of the flame supports the weld metal already composite manipulation rod all combined. Keep molten metal in the puddle from running and falling. 512 shows the flame and the rod motion backhand technique and direction of the weld movement over the welding rod, movement of the flame. Soundness and strength of the weld depends on the quality of the welding rods used. If you have any doubt about the quality of the rods, you're not sure of the type of the used, then it would be to your advantage to contact with the manufacturer, one of his distributors, if the rod is supplied through the federal stock system. Supplier personnel should be able to look up the information based on the federal stock number of the rod. This shows a pipe clamp, elbow clamp, an angle pipe clamp, a flange clamp. The Lindy Company has a best method of fusing weld with a remarkable fast precision weld and high quality. Anyone use the process welding pipe, if they adhere to the following conditions: use excessive fuel gas flame, use a welding rod containing deoxidizing agent, use back-held welding technique. Following brief explanation of previously mentioned conditions: excessive fuel gas flame, the base metal of the strip that each reaches white and absorb carbon from the excessive fuel gas flame. Absorption of the carbon lowers melting point of the steel, thereby surfaces of the melt at faster speeds of the welding action. 2. Special welding rod deoxidizing agent recommended with the rod eliminated the impurity, prevents excessive oxidation of the carbon where it not action with considerable carbon. The most valuable strength and element of steel would be lost. Thus, even in the higher carbon and higher strength pipe, the weld metal is stronger and stronger than pipe material. 3. Backhand technique. The technique produces faster melting base metal surface, also smaller bevel could be used. The result of the saving 20-30% of the welding time rods and gases. One of the most valuable types of the can use the weld pipe is the pipe clamp. The pipe clamps hold the pipe perfect alignment with the tack welds that are in place. They are quick and open, and you can move it and attach them quickly. Figure 13 shows the 4 different types of chain clamps that use the pipe welding. If these clamps are not available, you can fabricate your own by welding 2 C clamps to the piece with a heavy angle iron and a piece of 3/8 of an inch angle of the iron with 4 by 4 inches by 12 inches is easily suitable. When working with a small diameter pipe, you can lay it in a piece of the channel iron to obtain the true alignment of the butt welding. When the pipe you're working on has a large diameter, you can use a wide flange beam alignment purposes. Chapter 6: Soldering, brazing, braze welding, and wear facing.